Good morning, everyone, and welcome to this lecture. This is lecture number 1 on communication system, and we will see what a communication system is all about. Do you know what is a communication system? Any idea what is, sorry, a communication system? Have you heard the term communication system ever? No one has heard the term communication system?
No.
Okay, good. Now, the way that you can see me or you can hear what I can say is through a communication system. Any way that we are communicating with someone who is far off is through a system, through some sort of system that is known as a communication system. Now, just to give you a very brief structure of a communication system, what does a communication system consist of? We have an information source. Right now, I am the information source. This information source is generating a message or a signal, and the message or the signal to you is in the form of video and in the form of audio. Now, this message signal is then transmitted through a transmitter. Right now, the transmitter is the laptop, all these devices that I am using. These are the video cams. These are all the transmitters that I am using to transmit the system. Also the cable, the Wi-Fi system, the Wi-Fi coverage in my house that is carrying this signal. This Wi-Fi coverage is via optical fiber. That optical fiber, all these are helping me in creating a signal which is transmitted. That signal is known as transmitted signal. Now, this transmitted signal goes through a channel, as I told you. It is going through a channel, through the Wi-Fi thing, through the hardware, through the satellite links, through optical fibers laid under the sea and all that. And it is getting onto the other side where you have a receiver. The receiver is the screen and that audio system that is put in your class. That receiver receives the signal and you are the user who is using that information. In between all this, there is some noise, some disturbance that comes. Sometimes you might not hear my voice correctly. Sometimes the picture may not be clear. All these things are known as noise. So this is the basic structure of a communication system. A block diagram, a flow diagram. I'll give you a minute to note it down. Whenever we are talking about the modes of communication, there are two basic modes of communication. The first mode of communication is known as a point-to-point, and the second mode of communication is known as a broadcast. Now, what is point-to-point? Point-to-point is one transmitter, single transmitter, a single receiver. If you talk to someone on a phone, it is known as a point-to-point communication. The other type of communication is known as a broadcast, in which There are large number of receivers. Your satellite television is a broadcast. Radio and television are examples of broadcast, whereas telephony is an example of point-to-point communication. Do we understand this? Do we understand this?
Yes, sir.
I'll give you a minute to note it down. Then we come to what is information. The first element of communication is information. Information is what I am giving you. So information is nothing but a idea or a message that has to be conveyed. This message can be a single message or a group of message and so on. Now this message is converted into a signal. A signal is a single valued function that conveys the information. Right now the signal is the signal that I am transmitting is telling you about this communication system. Do we understand this? What is signal and what is information? Information is what I want to convey to you. Signal is the means by which this information is conveyed to you. We understand this? Are we there in the class, beta?
Yes, sir.
Do we understand this?
Yes, sir.
Okay. Now, whenever we talk about signals, you must understand that there are two types of signals. The first one is known as an analog signal and the second one is known as a digital signal. Can anyone tell me what is an analog signal and what is a digital signal? I think we discussed it in the last class. Can anyone recollect what is an analog signal and what is a digital signal?
Sir, analog is a continuous varying signal. Like it's like a wave in representing it.
An analog signal. An analog signal is like a wave. What about a digital one?
Yes, sir.
What is a digital then?
Digital has only two discrete values, sir, like 0 and 1.
A digital signal has only two discrete value binary system. We heard a lot about this binary system in the previous class. That is exactly correct. This one is an analog signal and this one is a digital signal. Do we understand this?
Yes, sir.
Analog signal and digital signal. I'll give you a minute to note it down. Note it down fast. Since we have understood what is a signal, signal is what I want to transmit. Signal is my information converted into things which can be transmitted. Comes the next element, and the next element of this system, communication system, is known as a transmitter. And as you can understand, the meaning of the word transmitter gives us what a transmitter do. A transmitter processes the incoming message signal so as to make it suitable for transmission. This camera is getting some input from me and it is converting this input and making it suitable for transmission. This is known as a transmitter. Do we understand this? A transmitter consists of a transducer, a modulator, amplifier, and antenna. What is a transducer? Transducer converts different types of signals into electrical signals so that they can be transmitted. A modulator, it mixes the electrical signal with high frequency radio wave. They are talking about radio waves. You can just talk about waves in general. Modulation is a very important part of this chapter and we will see what is modulation. So a transmitter consists of a transducer which converts any signal into electrical signal, a modulator which puts it or mixes it with a high frequency wave, an amplifier which amplifies the power of the signal so that it can go further, and an antenna which is going to transmit it. Do you see this?
Yes, sir.
The first one is the source of information right now, that is me. The second one is a transmitter which consists of a transducer which is converting signal into electrical signals. Then there is a modulator which is trying to put it on a high frequency wave. Then there is an amplifier which is amplifying the signal, and through antenna, there is no antenna here, there is a Wi-Fi cable over here that is transmitting the signal. Do we understand this?
Yes, sir.
You have 2 minutes to note this down. The next one is the communication channel. A communication channel, just write the term communication channel. And what is the function of the communication channel? The function is to carry the signal. Do we understand this?
Yes, sir.
You have to note down the important points. For radio, the communication channel is free space. For telephony, it is a transmission line. They're talking about fixed telephone lines. And then for optical communication, which is the Wi-Fi and the fiber cable that I'm using, it is optical fiber. Do we understand this?
Yes, sir.
Noise refers to unwanted signals. Whenever I'm transmitting or whenever this signal is transmitted, there are unwanted things that come in there. These are known as noise. Then receiver extracts whatever is on your side is a receiver. I mean, that's a transmitter as well, because I can hear your voice. But when I'm talking and you are seeing and you are listening, that is a receiver, and it extracts the message, extracts the signal and gives you the message. Do we understand this?
Yes, sir.
Note it down fast. Now the signal is transmitted through a communication channel, and we are receiving it through a receiver. Receiver consists of the same thing but in the reverse order. It consists of an antenna which picks up your signal. Right now there is no antenna. Again, there is optical fiber on your side which is receiving the signal. Then there is a demodulator which extracts the signal from the modulated wave. Then there is an amplifier which may be amplifying the weak signal that is coming. And there is a transducer. Again, it converts the electrical signal into pictures and sounds, and that you see. You understand this? It's the reverse of this.
Yes, sir.
You have 2 minutes to note it down. And remember, this chapter is all about understanding the terms and remembering them. The next terms are attenuation. What is attenuation? Whenever the signal is getting transmitted, we call it propagate. It's going from here to here. It will lose some strength. The signal that I am transmitting may not be same as the signal that you are receiving. That loss in signal is known as attenuation. Amplification, process of increasing the amplitude and the strength of the signal is known as amplification. You don't have to write the other thing. Amplification is just increasing the amplitude. Range, it is the largest distance between a source and a destination where signal is received. Your FM band, when you go out of the city, you will not receive any signal. Bandwidth, you must have heard this term bandwidth, refers to the frequency over which an equipment operates. If you have more bandwidth, you will have more good quality of signal. Modulation and demodulation, the original signal that I am producing may be of low frequency and it cannot be transmitted. Therefore, information contained in the low frequency message is superimposed on a high frequency wave. High frequency wave, this low frequency signal is put on a high frequency wave so that it can be transmitted. This process is known as modulation. Is the meaning of all the 4-5 terms clear to everyone?
Yes, sir.
Note it down in short, simple language and do it fast. There are two more smaller terms. Demodulation. Modulation is done at the sender's end, whosoever is transmitting, the transmitter's end. Demodulation is the reverse process in which that low frequency signal is extracted from that mixture of high frequency wave, and this process is known as demodulation. Sometimes you may place a repeater. It is a combination of transmitter and receiver. It receives the signal from one point and transmits it so that the signal can be transmitted over a large range. You can see a large number of repeaters put over here. I also have a Wi-Fi repeater in my house because my Wi-Fi device is on my first floor. It does not, the signal in the ground floor is not good, so I have put a Wi-Fi repeater. It receives the signal from my Wi-Fi source and transmits it in the ground floor rooms. Do we understand this? Repeater. It repeats. I'll give you 2 minutes to note it down. Just note down the important points and that's it. Well done, sir. Then we quickly move on to the type of communication system. You can just draw this. They're asking knowledge-based question these days, so they might ask you this question: what are the types of communication system? Depending on different bases, based on the nature, based on the mode of transmission, on the transmission channel and the type of modulation, we can divide it into different types. On the nature of modulation, we can call it speech, picture, fax, data. No one sends fax these days. On the basis of mode of transmission, analog or digital. Do we understand this?
Yes, sir.
On the base of communication, line communication, point to point, space communication over a vast area. Based on modulation, we have amplitude modulation, frequency modulation, phase modulation, that is in continuous wave. Then if you have pulses, then you have PAM. PAM, let me write what is PAM. PAM stands for pulse amplitude modulation. Pulse amplitude modulation. Here T stands for pulse time modulation. Here C stands for pulse code modulation. Pulse time modulation is two type. Pulse position modulation. So here P stands for position and W stands for the width of the pulse. We will just have to need to know the meaning and nothing else. I'll give you 2 minutes to note this down. Anyone understands this?
Yes, sir.
Then we come to this small thing, antenna. What is an antenna? It is used for transmission as well as reception. It transmits as well as it receives. The next important point is the size of an antenna. The size of an antenna should be at least lambda by 4, where lambda is the wavelength of the signal. If the wavelength of the signal is large, you should have large antenna. Wavelength of the signal being large means frequency is small. Do we understand this?
Yes, sir.
The second point you must understand is the power radiated by the antenna. The power radiated by the antenna is inversely proportional to the length square. Length is more, power is less. I'll give you 2 minutes to note this down. Just note down the important point, nothing else. You may not draw the diagram, it's of no use. Do you understand what I'm saying?
Yes, sir.
Let us try to understand how we can find out the length of antenna using this simple example. This is show that just have to find out the minimum length of the antenna, and I have a signal of frequency 10 megahertz. Remember, what is the minimum length of the antenna? It is lambda by 4. Do we understand this?
Yes, sir.
Now, the only other equation that you know is C is equal to F lambda, where C is the speed, F is the frequency, and lambda is the wavelength. So from there you can find out the wavelength. Remember, all these signals, they're traveling with the speed of light, yes or no?
Yes, sir.
So 3 into 10 raised to the power 8 is the speed of this signal, and 10 megahertz is 10 into 10 raised to the power of 6. Everyone understands this?
Yes, sir.
Now if you divide this, you will get the wavelength as 30 meters. So the minimum length will become 30 divided by 4, and that would be 7.5 meters. This is how you can find out the minimum length of the antenna. Everyone understands this, yes or no?
Yes, sir.
Have you understood the importance of this? How we can find out from frequency, we can find out the wavelength, from wavelength we can find out the minimum length of the antenna that is required. I'll give you a minute to note it down. Have you noted it down?
Yes, sir.
Now we come to the next heading, which is propagation of electromagnetic waves. You don't have to write everything, you just have to understand what is this propagation of electromagnetic wave. In communication using radio waves, we have an antenna at the transmitter, radiates the electromagnetic wave, EM wave, which travels through the space and reaches the receiving antenna. Do we understand this?
Yes.
When this wave is traveling, it will lose some signal. The strength of the wave keeps on decreasing. Yes or no?
Yes, sir.
Several factors will influence the propagation. Now we are going to understand how does this wave, how does this EM wave propagate. Do we understand this?
Yes.
Now, depending on the type of wave, we can have different types of this EM waves, and again you just have to note down the important points which I am going to highlight. The first type of wave is known as a ground wave. The first type of wave is known as a
Ground.
ground wave. We have seen that to give out signals, the antenna must be having a size lambda by 4. Yes or no?
Yes.
If the wavelength becomes very high, very large, the size of the antenna will become very large. If you have seen all these TV broadcast station, you will see a very large dish. At some point in time, there were dish TV that came in India the first time, and we had very large dish that was needed to receive the signal. Right now, your Tata Sky or your this has a very small dish. Do we understand this? So, if you want to transmit signals over of large wavelength, the size of the antenna becomes very large. Do we understand this?
Yes.
Now, these large antennas are located very near to the ground. You must have heard AM broadcast. Do you understand AM broadcast?
Yes, sir.
AM band of radio, FM band of radio. This AM broadcast is generally done with all these antennas which are put on ground. This wave will propagate along the surface, and these waves are known as ground waves. Do we understand this?
Yes, sir.
So AM, your radio AM waves are transmitting through ground. They are not transmitting through ground, they are very near to the ground, and they are known as ground waves. The maximum range of coverage depends on the transmitted power and frequency. You can only transmit a few megahertz, because if your frequency becomes high, sorry, yes, you can only transmit less than a few megahertz. If your frequency becomes less, your wavelength will become more and the size of antenna will keep on increasing. Do we understand this?
Yes, sir.
If the frequency is more, then wavelength is less, then you can transmit it. If the frequency is less, then wavelength becomes more and antenna size becomes more. So this ground wave is only suitable when wavelength is less, that means frequency is high. Do we understand this?
Yes, sir.
You just have to note down the important points. I'll give you a minute to note it down. You can summarize these ground waves in terms of these 4 points. So I have taken out a point-wise thing of this. Ground wave propagation, radio waves will travel along the surface of Earth. Point number one. They will induce current, so some energy is lost. The decrease in this value of energy increases with the increase in the frequency. Then this ground wave is only possible from 500 kilohertz to 1500 kilohertz. These are the important points. You just have to know them now. Do we understand this?
Yes, sir.
Then we have the second mode of communication, which is known as skywave. What happens here is this transmitter will send you a wave in the atmosphere, and from the ionosphere it will get reflected back. That is the only thing you have to understand. These waves are getting reflected back from the ionosphere, and it is suitable for communication till 30 megahertz. Do we understand this?
Yes.
And they can travel very long. Do we understand this, everyone?
Yes, sir.
Note it down fast. And it comes to the third type of communication, which is known as space wave communication. These are radio waves of very, very high frequencies. Since they are radio waves of very, very high frequencies, the wavelength is very small and you can transmit it from one tower to the other tower. This is also known as line of sight communication. Do you see this transmitting tower over here, HT? Yes or no?
Yes, sir.
Do you see here the receiving tower, HR? Yes or no? So from tower to tower, it is known as line of sight communication. This DM is the maximum distance through which this can travel over the curvature of Earth, and the value of this DM can be written as 2R ka root plus 2R ka root. DT is the distance through which it can be transmitted, that will be equal to root over 2HT. You will have to remember this formula. HT is the height of the transmitting antenna and HR is the height of the receiving antenna. Do we understand this?
Yes.
This is used for very, very high frequency from 30 to 300. Remember this. I'll give you 2 minutes to note it down fast. You can also understand this thing by this diagram where we have this transmitting antenna. You can have this as the Doordarshan antenna. It is of a height h. Do we understand the height h? This is the height h of the antenna, and you can see this is the distance d. Up to what distance it can transmit, and the distance through which it transmit will be 2HR. That is what we have seen. Yes or no?
Yes, sir.
Now sometimes they ask you for a TV channel how much will be the area covered. This area covered will be equal to pi into d square. This pi into d square, it will be the area covered, or you can write it as 2 pi rh, because d is under root of 2hr. Do we understand this?
Yes, sir.
Sometimes they also ask you how much population will be receiving this broadcast. So to understand the population, you can just multiply the density of population by the area. Do we understand this?
Yes.
Density of population means population living in a unit area. Do we understand this?
Yes.
I'll give you 2 minutes to note this down. Remember, this chapter is about remembering a lot of things. These are the different frequencies. 3 kilohertz to 30 is known as very low. Then the next one is known as low. The other one is medium. Then it is high. Then it is very high, ultra high, super high, and extremely high. You don't have to remember the wavelength range. You have to remember the frequency range. And then you must remember where they are used for. They're asking you questions based on this, and straightforward questions can appear in the exam based on this. I'll give you a minute to note this. Okay, then we move on to some question and answer. Remember, any one of these questions may land up in your exams. This is the first one. In which frequency range space waves are normally propagated? HF, VHF, UHF, SHF.
Very high frequencies. Option 2.
Option 2, space waves. Very high frequency. It's from 3 to 30 megahertz. Space waves are from 30 to 300 megahertz.
Very high frequency only, no, sir?
Yes. Very high frequency. Very high frequency. VHF. Very high frequency. That is where you operate these space waves. Okay. Now this is again information based question. Just notice down, an antenna behaves as a resonant circuit when its length, and you must remember that its length must be lambda by 2 or integral multiple of lambda by 2. Just notice down as a point rather than a question. Note it down as a point rather than a question. Okay, when will an antenna behaves as a resonant circuit? If wavelength if its length is integral multiple of lambda by 2. Just note it as an important point. Have you noted it down?
Yes, sir.
The next question is this one. The process of superimposing a signal frequency onto a carrier wave is known as what? Remember, these questions are all about your, yes, remembering things. The process of superimposing a signal frequency onto a carrier wave is known as?
Modulation.
It is known as modulation. Remember, any one of this question is going to end up in your exam. So remember these things and remember how questions are asked. Long distance short wave radio broadcasting uses which wave? Ground wave, ionospheric wave, direct wave.
Sky waves.
Yes,
Sky wave.
sky wave. What are sky wave?
They're used for long distance.
Sky wave is here where it gets reflected from the ionosphere. Yes or no?
Yes.
Radio waves move like this or they move like straight? They move like straight, no? Or they get reflected from the ionosphere. You can also see their range. They are space waves.
Space.
Direct from antenna to antenna. So the answer is they have given it in a different way. It's a direct wave, point to point. I mean, one antenna to the other antenna. Do you understand this? One antenna to the other antenna.
But the long distance and short wavelength is sky waves, right?
I gave you example of this TV antenna. Yes or no?
Yes.
One point to the other point. How does a TV signal reach? This is how a radio signal reaches. Direct wave, space wave. Remember it.
Okay, sir.
I gave you that, right? That is why I'm giving you questions so that you understand in which, in what different ways or language a question can be asked. Next one. Whether it's a question of TV transmission or is a question of radio transmission, the question remains same. The maximum distance up to which a TV transmission from a TV tower of height h can be received is proportional to. Can I have the answer for this one? I have a TV tower of height h. Up to what distance can I see the transmission? Maximum distance.
Option 1.
Option 1, h raised to the power of half. Remember the distance is under root of 2hr. We remember this, yes or no? No or yes?
Yes, sir.
Let me ask you this one then. You'll have to give me the answer by calculating. A transmitting antenna is the top of a tower of height 32 meters and the height of the receiving antenna is 50 meters. What is the maximum distance between them for satisfaction communication in LOS? LOS means line of sight. Given that the radius of Earth, you'll have 2 minutes to give me the answer for this one. So, what is the answer, my dear friends?
4,000.
So, the maximum distance is under root of 2r into ht plus under root of 2r into hr. Yes or no?
Yes.
You just have to put the values. Height of the transmitter is 32. Height of the receiver is 50 meters. Yes or no?
Yes.
And the answer that I have is coming approximately equal to 144 into 10 square into under root of 10. That is the answer that I have. So you can check it. Remember, similar question you will see in your examination hall. That is why I'm doing a lot of questions on this. Remember, there are not many questions based on this. So whatever questions are, do them nicely. So the answer for this one is this, and it is given as approximately 45.5 kilometers. I hope you have got the answer for this one. Did you get the answer for this one?
We got a bit near values, sir.
Okay. This is a question from JEE Main of 2019, and as I told you, questions that are coming these days are based on your knowledge and your remembrance, how good you are at remembering things. So this is the question given below in the left are different modes of communication during different types. Which matches which? Now, if you remember any one or two of this, you should be able, you may not remember all. I've given you that table. From that table should come the answer. I'll give you a minute to just find it out. Well, the answer for this, I don't know how many you know. Optical fiber. Optical fiber is in the range signal of infrared lights depending on the frequencies. Radar, P, radar, and in radio waves, RR. Sonar, ultrasound. Mobile phones, M, microwaves. The correct answer is option C. I'll give you a minute to note it down. Let me move ahead and do all these types of question. This is again a question based on your knowledge. It's simple. We have already seen it. The physical size of transmitter and receiver antenna in a communication system are the size of antenna proportional to what? I'll give you a minute. I'll give you a minute to give me the answer for this one. Remember, well done. The size of the antenna, minimum size of the antenna should be equal to lambda by 4. So this is directly proportional to lambda. So it is inversely proportional to frequency. Frequency of what? Frequency of the wave which is carrying it. That is why we superimpose it on a carrier wave so that it can be transferred to long distances. I hope everyone understands this. Let me move ahead with the next question, and you can see this question you might have seen, and as I said, even in the class, I have told you many times that the same question that we do in the class, the same question will appear in your examination hall, and this is an example of the same question appearing in 2019. In a line of sight radio communication, the distance is about 50 kilometers is kept between the transmitting and the receiving antenna. If the height of the receiving antenna is 70 meters, then what is the minimum height of the transmitting antenna? I'll give you 2 minutes to give me the answer. So the only formula that you will have to remember is minimum distance is under root of, if you want, you can remember in this way, 2 times r bracket under root of ht plus under root of hr. We can remember it like this. R, the radius of earth is 6.4 into 10 raised to the power 6 meters. You have to find out the height of the transmitting antenna. So that is what you need to calculate. The height of the receiving antenna is 50 kilometers. When you put down the values and you calculate the this HR, height of the receiving antenna, is actually given as 70 meters, and the distance between the two is given as 50 kilometers. So I can just write this equation: 50 into 10 raised to the power 3 will be equal to under root of 2 into 6.4 into 10 raised to the power 6. in the bracket under root of ht, which you have to find out, plus under root of receiving antenna 70. From here you should be able to calculate the value of ht, and the value of ht that you are getting, the answer given to me is 32 meters. So I'll give you that answer. I'll give you a minute to note it down. Once you note it down, please let me know. And again, this is a question from 2019 JEE Mains. To double the covering range of a TV transmission tower, the height must be multiplied by how much? How much would be the height if I want to double the range?
D. Sir, option D. Sir, option A.
Distance is under root of 2hr. I have to double this. So the height should be made 4 times. I'll give you a minute to note this down. The next question is this. Again, it is an information based question. The wavelength of the carrier waves in a modern optical fiber. I'll give you a minute. Remember, the answer for this one is approximately 1500 nanometers. So just note it down. Remember, some questions are based on your information. If you know it, you know it. If you don't know it, the question will just disappear. So this is one of those questions which you must know the answer beforehand.
Sir, 1 minute.
Note it down. Have you noted it down? Okay.
Sir, 1 minute.
Noted it down? Let me know once you're done. And again, this is a question from 2019 JEE Mains. A transmission tower has a height of 140 meter and the height of the receiving antenna is 40. What is the maximum distance? Again, you must calculate and give me the answer. Option A is correct. dm is under root of 2r ht plus under root of 2r hr. The radius of the earth is given as this. The transmission antenna height is given as this. The receiver antenna is given as this. You put all these values and I think you will end up with some calculations. At this point, the maximum distance it can travel is 65 kilometers. I hope you have now understood what type of questions can come on this one. You understand this
Yes, sir.
now? You can do this problem as well just to get more confidence on if this type of problem comes, what would be your answer? What should be the height of the transmitting antenna if the TV telecast is to cover a radius of 128 kilometers? The average population density is 1000 per kilometer square. How much population is covered? I'll give you 2 minutes to give me the answer for both the parts. Let me know once you are done. So, you know, the distance is given as under root of 2hr. Yes or no? From here, I can write h as d square by 2r. So the height of antenna will be 128 kilometer. So I squared it. 128 into 10 raised to the power 3 square divided by 2 into 6.4 into 10 raised to the power 6, and the height will come as 1280 meters. So you can see it should be 1280 meters. Very large distance to cover 128 kilometers. Anyways, the area that it will cover, the population that it will cover, population it would cover will be equal to pi d square multiplied by the population density. So pi into 128 into 10 raised to the power 3 square multiplied by 1000, and the answer that is given to me is 5.14 into 10 raised to the power 7 people or population would be receiving this broadcast signal. I'll give you a minute to note it down. Then let's move ahead to the next question. And the next question is here. In a communication system, noise is most likely to affect the signal where? I'll give you 2 minutes to give me the answer. And the answer is definitely option B, in the transmission line when it is getting transmitted. That is where noise comes in. Do we remember this?
Yes, sir.
Again, a question based on your information. I want you to see all types of question that can come so that when it comes, it will not be a surprise to you. This is the next one. The waves used in telecommunication are, I'll give you 2 minutes. What is the answer for this one? In telecommunication, microphones, mobile phones, microwave, mobile, micro, mm. Do we understand this?
Yes, sir.
This is the next one. TV signals on Earth cannot be received at a distance greater than 1000 kilometers. What is the reason? The option is option 4, because the surface of the Earth is curved. Because of that, you cannot have direct or line of sight signal, line of sight communication after a particular point, because then the curvature of the Earth would come into the picture. Do we understand this? Do we understand this?
Yes, sir.
That takes us to the next heading. And what is the next heading? The next heading. Okay, I have one more question. So let us do that question as well. You never know which question can come. One more question I have. So let us solve this one also, since I've taken it out for you. A TV transmission tower at Kota is at a height of 80 meters. Radius of the Earth is 6400 kilometers. What is the coverage reach? What population is covered? So what is the range or the distance? Remember, we have done so many questions. 2 times R into H. Yes or no? Are we there in the class?
Yes, sir.
So how much distance is coming? 2 into 6400 into 10 raised to the power 3 multiplied by 80. How much it is coming? The range.
740 into 10 power 3.
Ah, It is coming as 32 into 10 raised to the power 3 meters, my dear friends. 32 kilometers is the range. The area it will cover will be equal to pi into d square, and the population will be equal to pi into d square, 32 into 10 raised to the power 3 square, multiplied by the population density, which is 2000. The answer is 6430720. These are the numbers that is given to me. I hope we understand this.
Yes, sir.
Everyone understands this. We have done too many questions, all types of questions that were even remotely possible. I have covered it. Do we understand this? Shall we move ahead now?
Yes, sir.
We move ahead to the next heading, and the next heading is known as modulation. Modulation, my dear friend, modulation. What do you mean by modulation? Yes, we have already seen the meaning of this term, my dear friends. Tell me, what is modulation? What do you understand by modulation? Yes, yes, my dear friends.
Signal from low frequency to high frequency. Change. Low frequency to high frequency.
Low frequency to high frequency. What is the need of modulation? Well, why do we need to modulate? Why do we need to modulate the signal? These digital and analog signals that you have seen are usually of low frequency, and hence they cannot be transmitted. We have seen this, yes or no? So what we do is these signals require some carrier waves to be transported so that we can transmit them. These carrier waves are waves of high frequency. They are known as high frequency signals. So these low frequency signals are put on high frequency carrier waves. This process is known as what, my dear friends? This process is known as
Modulation.
this process is known as modulation. The process of what? The process of what? The process of changing some characteristics of a wave in accordance with the signal is known as modulation. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. Now, what is the need for modulation? Why do we need to modulate the wave? The first thing is length of the antenna. We have seen that this length of the antenna is lambda by 4. Yes or no? If the lambda is very high, the length of the signal, the length of the antenna will become very large, which is not possible. Yes or no?
Yes, sir.
Then operating range. Most of these are of small frequency, therefore they cannot be transmitted. That is why we need to modulate them so that they can be transmitted. We need them to go wireless. Now, if it is wireless, the efficiency of the radiation is very poor. So to increase that efficiency, we need to modulate. By modulation, we can send different messages with different frequency can be simultaneously transferred, and it also helps in avoiding the mixing of signals from different transmitters. These are the 5 uses. I'll also tell you a sixth one. The space is not there, so I'll tell you the sixth one. You just need to remember the headline. The first need is because of the length of the antenna. The second one is because of the operating range. The third one is for wireless. The fourth one is you can transmit different frequencies. The fifth one is we don't have mixing up of signals from different transmitters. Do you understand this?
Yes, sir.
Then we move on to the different types of modulation. We have the continuous wave, or you can say the analogous signal, which is a continuous wave, and then we have a pulse wave digital 0101. So we have continuous wave modulation and we have a pulse wave modulation. Now, in a continuous wave modulation, there are 3 types of modulation: AM amplitude, FM frequency, PM phase. Out of this, we will see amplitude and frequency modulation. Most of the questions are from that particular thing. We know this amplitude, frequency, and phase modulation. Yes,
Yes.
or no?
Yes.
Similarly, on the pulse modulation, the modulation on pulse, we have pulse amplitude modulation PAM, pulse time modulation PTM, pulse code modulation PCM. It's not physics, chemistry, maths. Pulse time modulation is of 2 times pulse width modulation PWM, pulse position modulation PPM. I'll give you 2 minutes. Oops. I'll give you 2 minutes to note this down. Well, this is modulation, and we will wind off this class here at this point. In the next class, that is tomorrow, we are going to see the different types of modulation. Now, remember, most of these things, how they are coming, how these equations are derived, would not be of much importance to us. What would be of importance to us is that we can remember the terms, the meaning of the terms that are coming. That is the most important thing. So in the next class, we will be having a look at the different types of modulations. We will also have a look at the different types of questions that have come and what you can expect in the examination hall. So I'll see you tomorrow. Take care. Have a nice day.